Assalamualaikum. We from Group BIM are going to present our system, which is Online Hospital Appointment System or HAS. Our group consists of 4 members. My name is Siti Nur Alia. My other teammates are Nur Amirah Nabila, Nur Haifa, and Nur Nabiha. So, without proper system to manage patients' appointment, hospitals may face some challenges. In many healthcare facilities, appointment records are still written manually on paper, cards, and handed to patients. This leads to issues such as lost records, forgotten appointments, and scheduling conflicts. As a result, long queues form at registration counters, causing patients to wait longer and healthcare staff to feel overwhelmed. Without an automated reminder system, some patients forget to come and the doctor time is wasted. So to fix these problems, we suggest using a digital appointment system. This system will help record appointments properly, reduce waiting time, and send automated reminders to patients so that everything runs more smoothly. Next, what we aim for this project is to allow receptionists to register patient details and schedule the next appointment directly in the system. Second is to send SMS or app notifications to remind patients about their upcoming visit. Third is to provide a secure patient login feature where users can log in using their IC number and password to check the appointment details. And lastly, to assist admins in analyzing appointment trends.
This is the list of functional requirements for OHAS project. The system is designed to support multiple users, roles including patient, receptionist, doctor, admins, and IT staff. Key functional include secure patient login, appointment scheduling and management automated notification, and the ability for a patient to confirm or reschedule their appointment. This requirement is for both patient and staff.
Next, I will explain the non-functional requirements. So these are the important qualities that make the system work well for everyone. So we have 9 non-functional requirements. NF1, which is about system should be available 24 hours. NF2, secure login with encrypted IC and password. NF3, mobile responsive and user-friendly interface. NF4, reminder messages at least 84 hours before. NF5, support at least 100 users at once. NF6, user-friendly error message. NF7, work with all major browsers. NF8, include sensitive data in the database. NF9 is fast response time.
This is the use case diagram for our online hospital appointment system. This diagram helps us understand how different users interact with the system and what features are available for each role. Our system supports 5 main actors, which are patient, receptionist. Overall, we have a total of 9 main features in our system. Register patient, schedule appointment, reschedule appointment, view appointment, confirm appointment, send appointment reminders, update visit status, generate report, and lastly, login and authentication.
So here's the first activity diagram and flow of event of register patient. It shows that patient or receptionist can register new patient if the data field is completed. It will proceed to save in database and send message. If not, user can re-enter all details. Next, they have to select date, specialty, doctors, and time. If there is no issue, it will update doctor's schedule and reserve appointment.
Next use case is view appointment. The actors involved are patient, receptionist, and doctor. This is for user to view their upcoming or daily appointment schedules. So the flow will start with user login into the system. Then user click on appointments icon. Then the system will display the appointment page. And user can either select to filter by date, doctor, or department, or not selected any filter. And if they select one of the option, the system will show the list for that option, such as doctor list, that range, or department list. Then user need to choose what they want and system will check either they have appointment or not. If there are appointment available, system will display the list of appointments. If not, display no appointment schedule.
Next, for the confirm appointment event flow and activity diagram, the process starts with the both patient and receptionist login. The receptionist review appointment request. If the slot available, the system reserve it, update the schedule, and send a confirmation to the patient. After receiving the confirmation, the patient can either confirm or reschedule. If they choose reschedule, they select a new slot and the system update the appointment accordingly. If any appointment details are incorrect, the receptionist can edit them, re-verify, and then confirm the appointment. If the appointment is missing or invalid, the system must show an error message. The receptionist can then retry or contact IT support for help.
This reschedule appointment can be done by patient or receptionist. It will display all appointments for user to select which appointment to reschedule. For a schedule, it will save the database and update doctor's schedule.
So for the send appointment reminder activity flow, event flow and activity diagram, the process starts automatically with the system checking appointment that approaching. If the reminder functionality is enabled, the system proceeds to the retrieve a patient contact info and generate message. Then it sends a message using the selected method SMS, email, or notification and log the action. Finally, the patient receives the reminder. If reminder functionality is disabled, the process ends early without sending anything.
Next, I will explain the update visit status. This feature is used by the receptionist to update the status of a patient's appointment after their visit, whether the patient attend. The will display the list of today's appointment. The receptionist selects the patient's appointment and then choose the new visit status. Once selected, the system will record the new. If the receptionist accidentally select the wrong appointment, they can cancel the update and select the correct one. However, if no appointment is found, the system will show an error message and stop the process. Next, for generate reports, this feature is used by the administrator only to generate reports, such as patient visits, doctor schedules, or appointment summaries. The process starts when the admin log into the system, then they navigate to the generate report section and select the report criteria such as date range or department. The system will process the request and retrieve the data. Then it will either display the report or allow admin to download it. No past data available, and ask them to choose the valid one. If no data match the selected criteria, the system will show no data found and cancel the report generation.
Then the last use case is login and authentication. The actors involved are patient, receptionist, doctor, and admin. This use case describes how user logs into the system using their IC number and password to access the functionality of the system. It starts by open the login page and user enter IC and password. Then system will verify the credentials. If valid, system redirects to the user's dashboard, while if invalid, system display error message, invalid IC number or password. From that, user can choose to retry or reset password. Then if user choose retry, then retries to log in. But if user choose reset or forgot password, system requests for IC number and send the reset code. Then user can reset the new password.
For high-level design and architecture overview, we are using layered architecture. So there are users such as patient, doctors, receptionists, and admin. It can interact with OHA's presentation layer. And business logic layer is for executing what user select in user interfaces. Then business logic layer can interact with database layer to save data or fetch data for user to view. Then there is external service for send message to user using SMS or email.
At the center of this diagram is an online hospital appointment system class, which manages a list of patients and appointments. This class includes all the core functionality of our system. For the class is one-to-many, which one system can manage many patients. OHAS and appointment class is one-to-many, which one system manage many appointments. Next, OHAS and view appointment class, which is one optional, which one actor can choose to view appointment or not. OHAS one-to-one, which administrator can generate one report per day. Lastly, OHAS and login manager is one-to-many. This class generalizes to all actors in the system, which are admin, doctor, patient, and receptionist. It means that all actors can log in many times to this system.
So I will continue to the component diagram for our online hospital system or OHAS. This diagram demonstrates the overall architecture showing how the system divided into 3 key layers: presentation, business logic, and database. For the presentation layer is the user interface, business logic layer is the core functional logic, database layer for data persistent and retrieval. So how the layer are interact? User login to the presentation layer. The login request goes to the authentication service in the business logic layer. That service verify credential against the user account database. Upon success, the user can access their dashboard and manage appointment. Any action like sending reminder or login activities are handled by the business logic layer and logged in the database. This layer approach improve maintainability, scalability, and security. That's all from our online hospital system. Thank you.